Dear learners, I am Pankaj Kumar Swarnakar, Assistant Professor, Chhattisgarh Swami Vivekanand, Technical University Bhilai. Welcome you all again to the course Essential of Surveying, Application and Technique. In today's lecture, we will continue our discussion on the case studies related to surveying operations. Our focus will be on case studies concerning canal surveys, which plays a crucial role in water resource engineering. The construction and maintenance of dams, canals and associated structures require precise calculation of earthwork, which are heavily dependent on accurate surveying techniques. We will start our discussion on these aspects to understand how surveying instruments are employed in such project. Today we will explore two important case studies related to leveling operation in canal construction. The first case study focuses on leveling in canal construction, where we will examine the critical aspects of leveling required during the initial phases of construction of a canal. In the second case study, we will discuss leveling operation in the repair and lining of a canal, highlighting the techniques and challenges faced during maintenance and improvement of existing canals. Following these case studies, we will work through an example problem for calculation of earthwork to further understand the practical application of these leveling techniques. So, let us start our discussion with case study number 1, which is leveling in canal construction. So, what is the problem statement and what is the objective? The problem statement is construction of a new irrigation canal in a flat agricultural region. The objective is to ensure uniform water flow by maintaining a consistent canal bed slope through the precise leveling. So, in this case study, in a flat agricultural region, an irrigation canal is being constructed to distribute water evenly across farmlands. But if the terrain is naturally flat, so it may possess a challenge in ensuring the water flows smoothly without any stagnation or any erosion. Proper leveling is critical in achieving the desired canal bed slope, which is necessary for efficient water distribution. I will again repeat because it is a very important point. Proper leveling is critical in achieving the desired canal bed slope, because if canal bed slope will not appropriate, then water will not flow smoothly. So, what are the steps involved in leveling for canal construction? The first step is surveying and leveling. The second step is setting out the canal bed, and the third step is excavation and bed preparation. We are going to discuss each step one by one. Now, the first step, which is surveying and leveling. A detailed topographic survey of the canal path is conducted to understand the natural ground level. Means existing ground levels are recorded. Based on discharge requirement and size of the canal, the required slope for the canal bed is calculated. For example, a gentle slope of 1:2000, which will be equal to 0.05%, is often used to ensure the water flows at an optimal speed without causing erosion or silting. So, what do you understand by a slope of 1:2000? It means for every 2000 meter along the canal length, the elevation decreases by 1 meter. This downward slope is essential because water naturally flows from a higher level to a lower level. Without this gradient, the water would not flow effectively through the canal. In mild slope, silting can occur where sediment settle and accumulate in the canal. On the other hand, if water flows with a high speed, because of steeper slope, scouring can take place which can erode the canal bed as well as bank. You may find silting and scoring to be new terms. So, let us take a moment to discuss them. The first term is silting. What is silting? Silting occurs when small particles like sand, silt or mud settle at the bottom of a canal. Over time, these particles pile up, reducing the depth of water and sometimes blocking the flow. You can understand silting by this figure. Now, what is scouring? Scouring is the opposite phenomena, where flow of water removes or erodes the soil, sand or other material from the bottom or sides of a water body. This can create deeper channel and sometimes even cause damage to the canals. You can understand with this figure. Now, the second step is setting out the canal bed. Leveling instrument like dumpy level or auto level are used to transfer the design slope to the ground. Temporary benchmark are established along the canal path at regular interval to guide the excavation. Since length of the canal is usually several kilometers, placing benchmark at regular interval allows us to check the accuracy of leveling with a nearby benchmark. This eliminates the need to return to the first benchmark repeatedly. Now, the step number 3 is excavation and bed preparation. The excavation is carried out following level marking given using instrument like auto level and dumpy level. Ensuring the canal bed maintains the uniform design slope means one person generally keep on instructing the person driving JCB that up to which level excavation is supposed to be done, so that uniform slope of canal can be maintained. After the excavation, the bed is checked again using leveling instrument to confirm that the slope is consistent with the design. Now, we will discuss importance of precise leveling. Ensuring the canal bed is leveled accurately is crucial for maintaining a consistent water flow. Even a slight deviation in slope can lead to waterlogging in some area or insufficient water supply in some areas. Means, if the slope of the canal does not consistently go downhill, the water won't be able to flow smoothly. Instead, it will stop and gather in certain areas, which can cause problems like flooding or blockages. This is why it is crucial to ensure that the slope is uniform throughout the entire canal. You can see this figure. This figure shows the blockage of the water. Precise leveling also minimizes the risk of erosion, which can weaken the canal structure and lead to costly repairs. If slope becomes steeper, then water will flow at very high velocity and erode the soil. So, after discussing this all, what is the outcome of this case study? So, in this case, the proper application of leveling techniques during the construction of canal ensured that water was distributed evenly across the farmland, improving crop yield and reducing the risk of erosion. Now, we are going to discuss case study number 2. What is the problem statement in case study number 2? It is the leveling operation in the repair and lining of a canal. So, we want to perform repair and lining of an existing canal suffering from water seepage and uneven flow. What do you understand by lining? Lining of a canal refers to the process of covering the bed and sides of a canal with a protective layer like concrete. You can see in this figure, it is a figure of lined canal. What is our objective? Our objective is to restore the canal's efficiency by lining it with concrete and ensuring the bed is properly leveled. So, here an irrigation canal that has been in use for decades is now experiencing issues such as water seepage through the canal bed and sides and uneven water flow due to silt deposition. The canal requires repair and lining to prevent water loss and restore efficient water distribution. Now, again I want to highlight about the lining of the canal, because this is a very important term in canal repair. Lining of a canal refers to the process of covering bed and side of a canal with a protective layer to prevent water seepage, to reduce erosion and to improve the flow of water. Common material used for canal lining is concrete. Now, I will discuss steps involved in canal repair and lining. First step is assessment and survey. Second step is excavation and leveling. Third step is lining the canal. So, let us discuss the first step. The first step is assessment and survey. A detailed survey is conducted to assess the current condition of the canal. Levels are taken to identify the areas where silt has raised the canal bed or the areas where erosion has lowered the canal bed. The survey data is used to plan the repair work, ensuring that the canal bed will be restored to its original designs. Now, the next step is excavation and leveling. Silt and debris are removed from the canal bed to expose the original surface of the canal. Any areas where the bed has eroded are filled and compacted. Leveling instruments are used to ensure the repaired canal bed matches the original design slope, which may be like 1:2000 or 1:3000. Lining the canal. The canal is lined with concrete or other impermeable material to prevent the seepage. The lining is applied uniformly following the leveled bed to maintain the desired slope. Regular check with leveling instrument like auto level and dumpy level ensure that the lining does not alter the canal slope, maintaining consistent water flow. Now, we will discuss importance of leveling in lining. Precise leveling during lining ensures that the canal retains its design slope, preventing problems such as uneven water distribution or excessive flow velocity that could damage the lining. Leveling also ensures that lining is applied evenly, preventing weak spot that could lead to future leaks. So, what is the outcome of this case study? So, the outcome of the case study is by properly leveling the canal bed before lining and during lining, the canal's efficiency was restored, which became lower because of seepage and other problem. So, water seepage problem was minimized and water flow become more consistent, leading to better irrigation and reduced maintenance. So, what is the conclusion of this case study? So, these case studies illustrate the critical role that leveling plays in both the construction and repair of canals. Proper leveling ensures that canal functions efficiently with water flowing at a desired speed and distribution, minimizing issues like erosion, seepage and uneven water delivery. By using leveling techniques accurately, engineers can ensure the longevity and effectiveness of canal system. Now, we are going to discuss an example problem, which is leveling in repair and lining of a canal. So, what is the problem statement? Problem statement is repair and lining of a 500-meter section of an existing irrigation canal with a bed width of 2 meters. The canal was originally designed with a gentle slope of 0.05%. Now, what is the objective? Objective is to restore the canal efficiency by ensuring the canal bed is leveled correctly and lining it with concrete to prevent the seepage problem. Here, the scenario is an old irrigation canal has been experiencing issues with water seepage and uneven flow due to years of use. The canal bed has accumulated silt in some areas, causing an uneven slope, while erosion has worn away the soil, creating uneven areas where ground has sunken, forming low spots in others. Now, what is our goal here? Our goal is to re-level the canal bed and line it with concrete to restore its original functionality. We will try to deal this with this case study step by step. First one is assessment and survey. Second one is excavation and leveling. Third one is volume of earthwork calculation. Fourth one is lining the canal, and fifth one is final checks and leveling. So, what is the original design slope? The canal was originally designed with a gentle slope of 0.05%, means 0.0005 meter per meter. What does it denote? It means for every 100 meter length of the canal bed elevation drop by 0.05 meter, or we can say 5 centimeter, as you can see in this figure. Now, current survey data is also with us. The following table shows the current bed level at every 100 meter interval. So, here you can see distance is given, original bed level means design bed level is given, and the current bed level is given. So, it is given in the interval of 100 meter, at 0 meter, 100 meter, 200 meter, 300 meter, 400 meter and 500 meter. What observation we can make using this table? Can you think of? We will discuss it in the second step. Second step is excavation and leveling. Based on the survey data as shown in table, the following observations can be made. At 0 meter section, original bed level and current bed level are same. So, there is no cutting filling required, whereas at 100 meter section, the current bed is slightly higher than the design level by 0.005 meters. At 200 meter section, the actual bed is lower than design level by 0.01 meter or 10 mm. So, it needs to be filled and compacted to raise it to the design level. What is the observation at 300 meter section? The bed is slightly higher by 0.02 meter or 20 mm, requiring cutting to reach the design level. What is observation at 400 meter? The bed is higher by 0.02 meter or 20 mm, requiring cutting to reach the design level. What is observation at 500 meter section? The bed level is 0.01 meter below the design level, requiring a small amount of fill. Now, in the calculation of earthwork for this canal, the basic assumption we must understand. It is assumed that cross sectional of the canal remain same for half of the distance between each pair of section on either side of the section being analyzed. Again I will repeat, because this is very important assumption. What is the assumption? The cross sectional area of the canal remains the same for the half of the distance between each pair of section on either side of section being analyzed. This assumption helps in calculating the volume of earthwork needed. If you are finding it difficult to understand, this figure may help to clarify the concept. Please see this figure. In this case, the canal is 500 meter long and cross section details means current bed level, are available at every 100 meter, which means bed level data is available at a total of 6 points along the canal length. We assume that the canal's cross section shape stays the same for half the distance between each pair of section on both sides of the canal. So, based on this assumption, we can divide the entire canal into 6 segments, as you can see in this figure. So, what is the important observation? A very important observation is for segment number 1 and 6, the length is 50 meters. Why? Because the canal data is available only on one side of section. For the other segment, the length is 100 meters as canal extend on both the sides. To calculate the volume of earthwork for the canal, we use the cross sectional area data from these bed level points and multiply it by the length of each segment. This approach ensures accurate volume estimation by considering the variation in cross sectional shape and length between available data points. Now, we will discuss volume calculations. So, here for the volume calculation, width of canal bed is required. So, it is given that canal bed is 2 meter wide. So, volume of earthwork can be calculated by this formula, which is volume equal to length into width into depth of cutting or filling. So, let us calculate volume of cutting and filling for each segment. So, for segment number 1, it is assumed that the cross sectional shape at 0 meter remains constant throughout the length of this segment. Length of the segment here is 50 meters. As we have discussed from the table, at 0 meter original bed level and current bed levels are same. So, depth of cutting or filling is 0 meter. So, volume can be calculated as length into width into depth of cutting or filling. Length is 50 meters, width is 2 meter, depth of cutting or filling is 0 meter. So, volume of earthwork will come out to be 0 cubic meter for segment number 1. For segment number 2, it is assumed that cross sectional shape at 100 meters remains constant throughout the length of this segment. At 100 meter, the current bed level is higher than design level by 0.005 meters or 5 mm. So, 5 mm cutting will be done. Volume of cutting can be calculated as length into width into depth of cutting. So, it will be 100 meter into 2 meter into 0.005 meter. It will come out to be 1 cubic meter cutting volume. For segment number 3, it is assumed that the cross sectional shape at 200 meters remains constant throughout the length of this segment. So, at 200 meter section, the actual bed is lower than design level by 0.01 meters or 10 mm. So, it needs to be filled and compacted to raise it to the design level. So, here the depth of fill is 0.01 meter. So, volume of filling can be calculated as 100 meters into 2 meters into 0.01 meter, means if you will calculate this, we will get the volume of filling as 2 cubic meter. Now, for this segment number 4, it is assumed that the cross sectional shape at 300 meter section remains constant throughout the length of this segment. At 300 meter section, the bed level is higher by 0.02 meters or 20 mm. So, it requires 0.02 meter cutting to reach the design level. So, volume of cutting can be calculated as 100 meters into 2 meters into 0.02 meters. After solving, we will get volume of cutting as 4 cubic meters. Now, for segment number 5, it is assumed that cross sectional shape at 400 meter section remains constant throughout the length of this segment. At 400 meter section, the bed is higher by 0.02 meters or 20 mm. So, it requires 0.02 meter cutting to reach the design level. So, the volume of cutting can be calculated as 100 meters by 2 meters by 0.02 meter. After solving, we will get volume of cutting as 4 cubic meter. Now, the last segment means for segment number 6, it is assumed that the cross sectional shape at 500 meter section remains constant throughout the length of this segment. At 500 meter section, the bed level is 0.01 meter or 10 mm below the design level. So, it requires a small amount of filling. Volume of filling can be calculated as length into width into depth of filling. Length here is 50 meters because this is the end segment. Width is 2 meter, depth of fill is 0.01 meter. After solving, we will get volume of filling as 1 cubic meter. Now, we will discuss about lining of the canal. Once canal bed is properly leveled, the next step is to line the canal with concrete to prevent the water seepage. The lining must follow the newly leveled canal bed to maintain the correct slope. The thickness of concrete lining may be taken as 0.15 meters or 150 mm, or it may be taken as 0.05 meter or 75 mm. Now, we will discuss final checks and leveling. After lining, the canal bed is checked again to ensure it maintains the design slope. Any deviations are corrected immediately. So, what is the conclusion of this example problem? By following precise leveling and lining practices, the canal was successfully restored to its original functionality. The water flows efficiently, reducing the risk of seepage and ensuring consistent delivery to the irrigation network. Dear learners, as we come to the end of our journey through the course Essential of Surveying, Application and Technique, I want to express my sincere gratitude to each of you for your dedication and active participation. We have explored the principles and practical applications of surveying, covering various techniques that are essential in the field. I hope this course has not only deepened your understanding of surveying, but also inspired you to apply these techniques in real world scenario with confidence. Remember, the knowledge you have gained here is a foundation. Continue to build on it. Stay curious and never stop learning. I wish you all the best in your future projects and careers. Thank you once again. Happy learning.